For decades, we've been told a story about how the universe began. A colossal explosion, the Big Bang, followed by the slow, patient formation of tiny baby galaxies that grew up over billions of years. It's a story of gradual assembly, like cosmic streams flowing into cosmic rivers, building the grand structures we see today. It's a story that made sense. But then, the James Webb Space Telescope looked back to the dawn of time, and that's not what it found. Instead, it's finding a whole population of impossible giants lurking in the primordial darkness, structures so massive they are challenging our understanding of how the universe was born. The 7 structures in the title represent this larger class of cosmic rule breakers that have astronomers scrambling for answers. To get why this is so stunning, you first need to understand the official story of the cosmos. It's called the Lambda CDM model, and it's our standard model of cosmology. It's been wildly successful, explaining the faint afterglow of the Big Bang and the large-scale structure of the universe we see today. According to this model, the universe is built from the bottom up. Think of it like building with Legos. You start with the smallest bricks. In the very early universe, just a few 100 million years after the Big Bang, the first stars were supposed to have ignited inside small halos of gas and dark matter. These were the proto-galaxies, the baby galaxies. The model predicted that Webb, with its powerful infrared eyes, would peer back into this cosmic nursery and find these galactic infants, small, clumpy, and just starting out. The theory was simple. Big things grow from small things, merging over a very, very long time. A galaxy as massive as our Milky Way should have taken billions of years to form, slowly gobbling up smaller galaxies and pulling in gas. So when astronomers pointed Webb towards the farthest reaches of space, looking back over 13 billion years, they expected to see the seeds, not the whole forest. The rule was clear. The further back you look, the smaller and less developed the galaxies should be. For a long time, this is what our best telescopes, like Hubble, seem to confirm. But Webb didn't just see seeds, it found giants. In a series of observations, peering into the universe as it was just 500 to 700 million years after the Big Bang, astronomers found a whole bunch of galaxies that, according to the models, simply shouldn't exist. These weren't the small, clumpy babies everyone expected. They were behemoths, shockingly mature and massive for their age. One early explosive study identified 6 candidate galaxies that appeared to be over 10 billion times as massive as our Sun. One of them even seemed to rival the mass of our own Milky Way, yet we're seeing it when the universe was less than 5% of its current age. Imagine our galaxy had billions of years to grow, yet these upstarts apparently did it in a cosmic blink. Another team, working on the Fresco survey, identified 3 more of these ultramassive galaxies, nicknamed red monsters because of their dusty red appearance in Webb's images. These galaxies weren't just massive, they were also incredibly efficient at making stars, converting nearly all their available gas into new suns with terrifying speed. This is the central mystery. It's like finding a fully grown adult in a hospital nursery just minutes after birth. It defies the known rules of development. These galaxies are too big, too mature, and far more numerous than our best simulations predicted. The first reaction from many scientists was naturally disbelief. This has to be a mistake, right? Maybe they weren't massive galaxies at all. Some wondered if they were supermassive black holes masquerading as galaxies, with their glowing accretion disks tricking us into thinking they were bigger. Or maybe they just weren't as far away as they seemed, their light reddened by cosmic dust to mimic extreme distance. This is where the real work of science kicks in. Teams from projects like the Cosmos Webb Survey, the largest program Webb undertook in its first year, began the meticulous process of verification. They used Webb's advanced instruments to dissect the light from these objects, looking for definitive chemical signatures and measuring their redshifts with much higher precision to confirm their true distance. After rigorous analysis, the stunning conclusion held firm. While some of the initial universe breaker candidates turned out to be less massive or had their distances revised, a significant number of these impossible giants remained. The data was solid, the distances were correct, the masses were enormous. The problem wasn't with the telescope, it was with our theories. The universe, it seems, was building massive structures far earlier and far faster than anyone had ever dreamed. So what does all this mean? Does this break everything we know about the universe? Not quite. This discovery doesn't torpedo the Big Bang Theory itself, but it does force a radical rethink of what happened right after. It presents what scientists call the impossibly early galaxy problem. Our understanding of how galaxies form, a cornerstone of modern cosmology, is facing its biggest challenge in decades. One possibility is that galaxy formation was just wildly more efficient in the early universe. Perhaps the cosmic breaks that normally slow down star formation, like supernova explosions, were less effective, or some unknown process was hitting the accelerator. Another, more profound idea is that the initial conditions of the universe were different. The Standard Model assumes a mostly smooth early universe with tiny density fluctuations that grew over time. To get galaxies this big, so fast, maybe those initial seeds were bigger than we thought, which could require a fundamental tweak to the Lambda CDM model itself. Some researchers are even exploring more exotic solutions. Could massive primordial black holes formed in the Big Bang have acted as gravitational anchors to jumpstart galaxy formation? Others point to alternative theories of gravity, like MOND, which predict that structures would form faster without needing conventional dark matter. We are standing at a genuine precipice of discovery. The James Webb Space Telescope hasn't broken the universe. It has revealed that it's more complex, efficient, and mysterious than we gave it credit for. These early observations are just the beginning. The Cosmos Web Survey alone has now released data on nearly 800,000 galaxies, providing an unprecedented cosmic playground for astronomers. Every new deep field image could hold the key. Are these massive galaxies common, or are they rare freaks of nature? What can their chemistry tell us about the universe they were born in? Webb continues to stare into the abyss, pushing further back in time, searching for even earlier structures. The story of our universe, a story we thought we had figured out, is having its first chapter seriously revised. We're in a new era of cosmology where the data is leading the theory, forcing us to question our most fundamental assumptions. The giants are out there, waiting at the dawn of time, and they have a story to tell about the true beginning of everything. If you want to stay on the front lines of these discoveries, make sure to subscribe. You won't want to miss what Webb finds next. And let us know your thoughts in the comments. What do you think is the secret behind these impossible giants? It turns out the universe wasn't patient. It didn't wait billions of years to start building its masterpieces. In the fiery darkness of its infancy, it forged giants. The detection of these massive structures is more than just a discovery. It is a challenge. It's a message sent across 13 billion years of space, telling us that our neat and tidy picture of the cosmos is incomplete. And thanks to Webb, we're finally ready to see what we've been missing.